A modern army doesn't depend only on soldiers, planes, missiles, and ships. It depends on a much less visible industrial supply chain: critical metals, magnets, alloys, electronic components, chemical refining, export licenses, and second or third tier suppliers. This is where one of China's most important levers against Western powers lies. Beijing does not yet have the same overall military power as the United States. Not the same network of bases, not the same ocean-going navy, not the same depth of alliances, but China controls an essential part of the materials and industrial processes that make Western technological superiority possible. So the issue is not just about rare earths in the strict sense, it is part of a broader picture. Rare earths, gallium, germanium, tungsten, lithium, battery components, refining technologies. In other words, the entire material base of the digital energy and military economy. What you need to understand is that the West has long thought of military power from the top down. The F-35, the aircraft carrier, the hypersonic missile. China, on the other hand, has methodically consolidated part of the foundation: extraction, refining, processing, intermediate materials. But without this foundation, advanced systems don't stop immediately, but they become harder to produce, more expensive to maintain, longer to replace. In a short crisis, this isn't necessarily decisive. In a long war, it can become central. So the question isn't whether China can push a button and immobilize Western armies tomorrow morning. No. The real question is, can it slow down their production, complicate their maintenance, and affect their ability to endure in a prolonged confrontation? Here, the answer becomes much more serious. Welcome to Terabellum. In this video, we're talking about an invisible dependency, the one that involves metals, magnets, components, and supply chains. But there's another dependency, more everyday, more personal, and often underestimated: our constant exposure online. Because ultimately, sovereignty isn't just about states. It also concerns our data, our access, our devices, our digital habits. And that's why this video is sponsored by NordVPN. With NordVPN's basic subscription, you have a simple, fast, and complete solution to strengthen your privacy on the internet. NordVPN encrypts your browsing data, masks your IP address, and allows you to change your virtual location. Very convenient, for example, if you are abroad and want to access certain French regional content. And above all, it's not just a classic VPN. The basic plan also includes anti-malware protection. It filters your traffic, blocks malicious domains, phishing attempts, and intrusive ads that slow down your browsing. You also have dark web monitoring. If your data appears in a leak, NordVPN alerts you and tells you the steps to take to secure your accounts. All of this can be used on up to 10 devices simultaneously: computers, phones, tablets, Apple TV, or Android TV. And NordVPN has a no-log policy. No user activity records are kept. By using my link in the description, you get 4 extra months on 2-year NordVPN subscriptions. With the basic subscription, that's less than €3 per month, with a 30-day money-back guarantee. Thanks to NordVPN for supporting the channel. Now let's get back to another form of dependency, one that could slow down Western armies in the future. Rare earths include 17 elements, the 15 lanthanides, plus scandium and yttrium. They are not all geologically rare, but they are rarely available in a simple form that's easy to exploit. They are often mixed with other minerals present in low concentrations, and their separation requires complex, costly, and polluting chemical processes. Their importance comes from their physical properties. Some of them make it possible to produce extremely powerful and compact magnets. Others can withstand high temperatures, improve the stability of certain materials, enhance lasers, or are used in specialized electronic components. In a modern economy, they are therefore found in motors, wind turbines, electric vehicles, sensors, radars, satellites, as well as guidance systems and military equipment. The most critical for defense are neodymium and praseodymium, which are at the heart of neodymium iron-boron magnets, essential for achieving strong magnetic power in a small volume. Dysprosium and terbium allow these magnets to maintain their performance at high temperatures, which is crucial in motors, actuators, or embedded systems subjected to extreme conditions. Samarium cobalt, on the other hand, is used when resistance to heat and corrosion becomes a priority. This detail is important because Western armies rely on miniaturization and performance. A fighter jet, a drone, a cruise missile, or a modern radar can't simply replace these materials with steel, copper, or aluminum without losing performance. And in some cases, there are substitutes, but they are often less effective, heavier, more expensive, or harder to integrate. So the subject is not trivial. Rare earths make up only a small fraction of the mass of military equipment, but they can determine some of its most critical functions. That's precisely what makes their supply chain strategic. We need to avoid a common mistake. China does not own all the rare earths in the world. The United States, Australia, Canada, Brazil, India, and several African countries, Central Asia, and even Greenland have resources. So the problem is not just the existence of the ore. The real bottleneck is industrial. Extracting ore is not enough. Then it has to be crushed, concentrated, the different elements separated, high-purity oxides produced. These oxides transformed into metals, alloys manufactured, and then integrated into certified components for the automotive, aerospace, space, or defense industries. Each step requires factories, expertise, energy, waste management, sufficient volumes, and customers capable of absorbing the production. It is in this complete chain that China has taken a considerable lead. This dominance is not a coincidence. Since the 1980s and 1990s, Beijing has supported this industry. It accepted significant environmental costs, consolidated its companies, and took advantage of the Western withdrawal from segments considered too polluting or not profitable enough. Western countries kept the most visible and profitable activities: design, final assembly, software, and weapons systems. They let go of a large part of industrial chemistry and materials processing. This was consistent with a globalization logic where prices took precedence over sovereignty. But in a context of rivalry between major powers, this choice has now become a vulnerability. China doesn't just control mines. It controls a processing capacity that others cannot quickly rebuild. A mine can be identified on a map. A refining and magnet supply chain takes years, sometimes even decades, to build. And in a strategic crisis, 5 or 10 years is a very long time. Western armies are not just consumers of rare earths. They depend on systems that use rare earths to maintain their qualitative advantage. That's an important distinction. Modern fighter jets use components made from rare earths in certain electrical systems, sensors, actuators, or subsystems. Drones use motors, sensors, stabilization systems, and electronic equipment. Precision missiles rely on guidance systems, control surfaces, electronic components, and sometimes specialized magnets. And as for radars, sonars, satellites, lasers, and night vision equipment, or guided munitions, they also rely on critical materials. The American Department of Defense mentions rare earth-based magnets in systems like the F-35 Virginia-class submarines, drones, radars, Tomahawk missiles, and JDAM guided bombs. These are not secondary pieces of equipment. They are platforms at the heart of American military power. The paradox is that defense represents a very small share of global demand for rare earths. Most of the demand comes from the civilian sector: electric vehicles, wind turbines, industrial motors, data centers, and even robotics. So the military is a political priority, but economically, it is a minor player. This means that the Pentagon, the French Directorate General of Armaments, or the European defense ministries do not control the supply chain on their own. They depend on a global market dominated by massive civilian needs. If car manufacturers, battery makers, or wind turbine producers experience a shortage, they compete with military needs for the same materials, the same magnets, and sometimes the same suppliers. The military issue is less about direct consumption by the armed forces and more about their reliance on a global industrial base. An army may have stockpiles of missiles, but if the production lines that are supposed to replace those missiles depend on rare components, its ability to regenerate becomes vulnerable. Now, a modern war consumes resources quickly. Ukraine has shown this. Drones, ammunition, and vehicles are continuously destroyed or worn out. The question is not just about having the best equipment at the start of a conflict. The real issue is being able to replace it for months or even years. China doesn't need to abruptly ban all its exports to exert pressure. A total embargo would be dramatic, but it would immediately push Western countries to speed up their decoupling. Beijing has a more flexible tool: export controls. Since 2023, China has increased restrictions on several critical materials, including gallium, germanium, graphite, and certain products related to rare earth elements. In April 2025, it added controls on several heavy rare earths and related products, before further expanding the measures in October 2025 to include certain components, equipment, and technologies related to rare earths. The logic is not only commercial, it is strategic. With a licensing system, Beijing can authorize certain flows, slow down some cases, request additional information, block certain uses, or create permanent uncertainty about timelines. This tool is less visible than a blockade, but can be very effective against industries that operate on a just-in-time basis. In the automotive, aerospace, or defense sectors, a delay on a single component can block an entire production line. Manufacturers don't always need tons of materials to be paralyzed. Sometimes a specific magnet, certified alloy, or qualified component not arriving on time can make Chinese leverage dangerous. They're not exactly cutting off access, just making it uncertain. Uncertainty forces companies to stock more, pay higher prices, find alternative suppliers, revise their production plans, secure longer contracts, and obviously accept additional costs. Global trade isn't disappearing, it's becoming conditional. And in a world of systemic rivalry, that condition becomes a weapon. We need to respond without exaggeration. China can't instantly stop Western armies. The United States and its allies have stockpiles, alternative suppliers, mines outside of China, recycling programs, and agreements with Australia, Japan, Canada, or the European Union. But saying that Beijing can't do anything would be just as wrong. China can slow down certain productions, increase costs, disrupt industrial schedules, and complicate ramping up in case of a crisis. The decisive point is not the equipment already delivered. An already produced F-35 doesn't stop working because a Chinese license is refused. The problem concerns maintenance, parts, and upgrades. The new series, replacement missiles, drones consumed in large numbers, and radars to be produced and stocks to be replenished. In a short confrontation, this pressure would probably remain manageable. In a prolonged war, it becomes much more serious. A modern army must be able to regenerate its capabilities, replace losses, repair damaged systems, produce new munitions, and keep its fleets available. China, therefore, has an indirect but real way to target the adversary's industrial tempo, not to prevent the West from waging war, but to increase the cost and reduce the speed at which it can sustain its effort. This is particularly important in a scenario around Taiwan. A crisis in the Taiwan Strait would involve a rapid consumption of missiles, drones, precision munitions, detection systems, and naval or aerial assets. If Beijing can simultaneously disrupt access to certain critical materials, it adds industrial pressure on top of military pressure. The leverage is therefore not absolute, but it is credible. Western countries recognize the problem, but fixing it will take time. The United States is funding projects for a full supply chain, from mining to finished elements. Europe is looking to extract, process, and recycle more critical materials within its own territory, while also reducing its dependence on a single external supplier. You can't simply order an industrial supply chain to be rebuilt. You need mines, factories, separation facilities, refining capacities, alloy producers, magnet manufacturers, standards engineers, and of course, funding and customers. And you also have to accept the environmental and political costs of these industries. That's one of the great paradoxes of Western countries. Everyone wants industrial sovereignty, but very few regions want to host mines, chemical plants, waste, and the necessary infrastructure. The issue of competitiveness will also have to be solved. Chinese supply chains gain from scale, an established ecosystem, and political backing. Western projects often face higher initial production costs. States will therefore probably have to guarantee prices, subsidize certain capacities, and accept that supply security will cost more than market optimization. The real conclusion is less dramatic than a scenario of total paralysis, but more serious. China cannot immobilize Western armies in the short term. But it can strain their industrial endurance. It can make war more expensive, production slower, maintenance more difficult, and planning more uncertain. A fighter jet, a submarine, a missile, or a drone is only the final part of a chain that begins in geology, continues in chemistry, goes through refining, and then ends up as a component that is sometimes tiny but essential. For a long time, the West considered these steps as secondary because they were polluting, not very profitable, or not seen as politically important. China, on the other hand, understood that they could become a source of strategic leverage. The issue of rare earths therefore forces Western powers to return to a simple reality. There is no lasting military autonomy without a complete industrial base. Doctrines, budgets, and alliances matter, but in a long war, those who control the materials, the factories, and the supply chains also control time itself to a degree. Thank you very much for watching this video. The Terabellum adventure has been going on for nearly 8 years, and without you, it wouldn't be possible. There are still about 45 of you watching our videos without subscribing. Please know that it's free, and subscribing as well as liking helps YouTube promote these videos to a larger audience. It helps us a lot to keep creating this content for you. Thank you, and see you next Sunday.